earth is filled with water, and out of that 71%, only 2.5% is the fresh water. That means the water that is fresh. But out of this 2.5% also, most of it is locked in the form of ice, in the form of groundwater and whatnot. Readily available water is just 1% of overall 71%. So, I'm talking in terms of the area of earth. If area of earth is 100%, then 71% is water and 1% of that is available. Another estimate is like this, that if I take that 71% as 100%, then only 3% is fresh water. And that 3% fresh water, or 2.5% or 3%, and that 3% of water is actually locked in the terms of ice caps or glaciers or groundwater. The accessible surface water is only 1%. Now, if you look at this 1%, this 1% water is in the form of rivers, water in my body, lakes, moisture in the soil, water vapors. You can see that this is a very important chapter as far as existence of life on earth is concerned. We have studied chapter on polymers, and we calculated that minimum 5 Nobel Prizes have been given in the area of polymers. Somehow the polymers interfere with water nowadays, and interestingly, water is one area where not a single Nobel Prize has been given as on date. If you look at your houses, you use RO water, you use different kind of water filters, everything is there, the technology has advanced. But if you look at some of the remote areas of earth, maybe the tribal areas of Africa or maybe India also, water is actually not accessible. Potable drinking water is one of the biggest problems of the present. I would say that if you aspire to become a Nobel laureate, try working on making available potable drinking water to remote areas of earth. That deserves a prize perhaps bigger than the Nobel Prize. Now let us come to the engineering part. Now, what are the engineering use of water, or use of water as an engineering material? It is used in thermal power plants for steam generation, and interestingly, we use fossil fuel to generate steam, and then steam hits on the turbines and electricity is generated. Then we use it as coolant also for irrigation purposes, for drinking purposes, for air conditioning, for washing. And when I say washing, I don't mean only cloth washing or our taking bath. I mean industrial washing. Actually, leather industries and textile industries uses a lot of water and contaminates it and throws it into the natural sources like groundwater. The water seeps into the ground with all the poisonous substances. It goes into the rivers and then it comes back to us in the form of drinking water. So you can understand that why this chapter is very important to you. Look at the important property of water. Now, water is a very interesting molecule because its latent heat of fusion and latent heat of evaporation and heat capacity of water is unusually high. So water, as compared to other liquids, has great capacity to hold heat, and that is why we call about superheated steam. Sometimes steam is used for heating many things. If you look at the molecule of water, this is oxygen and it has 2 hydrogens. H2O is the formula of water, and there is hydrogen bonding, and this hydrogen bonding between oxygen and hydrogen, and there is a covalent bond. So this is a normal small amount of chemistry that we can talk about water. Now let us move further and talk about that what are the sources or the impurities and the characteristics of water. Now let me tell you here, whatever is the source, so is the impurity in the water. जैसा भी पानी का सोर्स होगा वैसी ही उसके अंदर impurities होंगी. Now major sources of water, surface water is flowing water in rivers and streams. Then still water or stagnant water, which is in the lakes or ponds or in the reservoirs. Underground water, water from the wells and water from the springs that we normally take it out, then rainwater, then seawater. What kind of impurities water has depends. Now I'm going to show you the next part of this slide, which is impurities in the water depend upon its source. For example, dissolved impurities. When we talk of dissolved impurities, carbonates, bicarbonates, chlorides, sulfates of sodium, calcium, magnesium, iron, these impurities are actually come from rivers and streams, because rivers and streams, when pass through different soils, the soil contain all these salts and these impurities get mixed into the water. You may say that, sir, sodium, calcium, potassium, magnesium, iron, these are all required components of our body, so why you are calling them impurities? I agree that these are some of the cations which are required by our body, and that is why the water that you drink from by purchasing from the market is called mineral water. There is a limit. Beyond limit, then these are called impurities, and we will talk about that how they are going to affect our life and what do we need to do with the water that contains excess amount of calcium, magnesium, or iron or other salts. There are dissolved kind of things like oxygen we cannot call as impurity, but dissolved gases are also present in water, right? This is good. In fact, in your environmental lecture you are talking about COD and BOD, biochemical oxygen demand and chemical oxygen demand. This is not, but this dissolves. Carbon dioxide also dissolves in water, but we know that if carbon dioxide is more and oxygen is less, then the fishes will die, and then we call it as an impurity. Oxygen, no doubt, is not an impurity. It should not be come under impurity here. Suspended impurities, these may be inorganic impurities such as clay, sand, or organic impurities such as oil globules, animal matter, and vegetables. Now these are suspended, they can be seen. These impurities are actually present in lakes, ponds, and reservoirs. How in lakes, ponds, and reservoirs? Because in lakes, ponds, and reservoirs, when the water is stagnant, then there is some growth of the animal matter, maybe some kai, then breed kernel substance, or maybe some microorganisms, some kind of vegetables, or some oil globules. This is the suspended impurities. They are present in the lake water. Colloidal impurities, these impurities from the organic waste, finely divided silica and clay. These normally generally creep in water, or maybe from the rainwater, because we have suspended air dust particles into the air, and when rain comes, it absorbs those fine dust and silica particles and comes it. So colloidal impurities actually come from seawater. Then microorganisms such as bacteria, fungi, and algae, they again come from lakes, ponds, and reservoirs, sometimes from rivers and streams also. But actually stagnant water has algae, fungi, bacteria, and a glass of water may look very clean, but we are talking of microorganisms, and microorganisms are the organisms that have a size of 10 raised power minus 6 meters, and we cannot see it. Water may look very clean from a river or from a pond, but it contains certain microorganisms, and if we will drink it, they are going to harm us. Therefore, it is very important that we should treat water as per our requirement before using it. Sir, why did you not say that we should treat water before? My requirement may be different. If you have seen our campus, the water which is used for watering the lawns is different. That may contain some surfactants, some microorganisms, because we are not going to drink it. But water that we drink should not contain microorganisms. So as per my requirement, if I am going to, and that's why you guys have all kind of RO or the filters or different kind of fluorine treatment into the water, so just to kill bacteria. Now, analysis of water based on its characteristics. So one thing, then when we have to treat water, we need to know that what do we need to check for in the water. We need to look at first of all, physical appearance, that what is the color of water, what is the taste of water, suspended solids. For example, I went to one particular geographical location in North India, which was a bit rural, and water, the color of water there was yellow. And why the color of water was yellow? Because it has suspended sulfur particles into it. All the people who were using that water were first filtering it. They actually pass it through some RO or filter, but for washing and other purposes, they use the same water. Taste, if you go to another place, you see that okay, the water taste is different because the number of the composition, the salt, the source of water is different. So these are some of the things that are required for the analysis. And then suspended solids are, is the water clear? No, water में गंदला है यार, थोड़ा थोड़ा इसमें कुछ है, थोड़ी देर रख दो, उसके बाद इसको फिल्टर करके पिएंगे. Nowadays, no doubt we have filters, but you know, these are the physical appearances that we use. These are some of the things that actually are used to make water usable for the purpose for which we want to use it. For example, conductivity. Conductivity is the measure of ions present. We have discussed that water contains chlorides, sulfates of calcium, magnesium, sodium, iron, and whatnot. More ions will be present, more will be the conductivity. So conductivity is the measure of ions which are present. Then we can always measure the pH of water. That will tell me that how many H plus ions are present or what is the acidity of the water. Another parameter is TDS. Normally TDS means total dissolved solid. When I say TDS, RO, reverse osmosis instrument for purification of water, is not required everywhere. The companies are selling it just to increase their sales. And you know what are the disadvantages of RO? You use less water and waste more of it. You can see that there is a always, and reverse osmosis actually uses a filter membrane. Some of the water passes through that filter, rest is actually discarded, and you can see how much. In fact, RO is recommended if total dissolved solids are above certain limit, then only RO is required. Otherwise, there is no need of RO. I feel that the government should put heavy tax on RO because it leads to wastage of water. Turbidity, is that water is turbid or not? So, you know, these are some of the chemical properties. But what we will be discussing in detail will be the properties of hardness, that is quantity of ions present. Conductivity was a measure of ions present. You know, ions can be present in water. I can measure conductivity and get an estimate that how many ions are present. I can measure hardness and then I can know that how many ions are present. And then alkalinity is the measure of alkaline substances present in the water. So, you know, there are different ways of, these are all the chemical properties of water. Now I'm coming back to definitions. The alkalinity refers to the measure of capacity of water to neutralize the acids. Alkalinity is that water requires how much of acid to neutralize it. It's a simple titration as you have done into your practical classes. You take an indicator like ethyl orange indicator and then titrate it with sulfuric acid of known normality and find out how much acid has been used to neutralize the alkaline substances present in the water. It is the measure of presence of, you know, what can be the alkaline substances. The alkaline substances can be bicarbonate, carbon dioxide, hydroxide, and carbonate. All these substances, if they are present, they actually lead to alkalinity of water. We normally measure alkalinity of water. So if I have hydroxide, if I have carbonate, if I have bicarbonate, then I can titrate it with acid. How much acid was used in neutralizing all these substances is the alkalinity of water. Sir, you have written here carbon dioxide also, but you have not mentioned it here, carbon dioxide. Carbon dioxide, we will study in our next class that of carbon dioxide leads to alkalinity in water. If carbon dioxide is present in water, and then there are some salts present, then it leads to the formation of carbonates or bicarbonates. So carbon dioxide also accounts for the alkalinity of water. Now the second term, so I have discussed the term alkalinity, and this much of alkalinity definition is sufficient for this class. We will study a bit more about alkalinity in the next class. Now I am moving over to the hardness. Hardness is the property of water by virtue of which it fails to form lather with the soap due to presence of certain dissolved salts of calcium, magnesium, iron, aluminium, manganese. So that is called hardness of water. सर समझ में नहीं आया, दोबारा से बताओ. अरे भाई सोप लगाते हैं ना जब हम, तो आपने देखा होगा जब हम किसी नई जगह पे जाते हैं तो वहां पे क्या होता है, आप सोप रगड़ते रहते हो, हाथ में लादर ही नहीं बनती है, बिकॉज द वाटर एट दैट प्लेस इज हार्डर देन द वाटर एट योर प्लेस, एंड यू आर इन ए प्रैक्टिस ऑफ के थोड़ा सा रगड़ा, झाग भनी एंड साबुन साइड पर रखा, एंड देन यू मेक लादर एंड देन यू वॉश द हैंड्स. बट बिकॉज एट अनदर प्लेस द कैल्शियम एंड मैग्नीशियम आयंस आर मोर, तो आप सोप रगड़ रहे हो, लादर ही नहीं बन रही है, एंड यू कॉल इट एज हार्ड वाटर. So, you know, hardness is the property due to which water and soap together fail to make lather or form lather with difficulty due to presence of calcium, magnesium and other heavy metal ion salts. सर ये कैसे होता है? ये ऐसे होता है. आपका जो सोप है, what is that? Soap is a long chain fatty acid, C17H35 C double bond O, COO, carboxylate, you know, sodium dodecyl benzene sulfonate. So you know it's a long hydrocarbon chain which is soap, और उसका salt है sodium. Now this particular salt is actually soap which is soluble in water. तो अगर आपका पानी में कोई कैल्शियम मैग्नीशियम नहीं है तो ये सोप पानी में डिसॉल्व हो जाएगा और लादर बन जाएगी. इमेजिन दैट योर वाटर कंटेन्स कैल्शियम और मैग्नीशियम या आयरन के सॉल्ट्स. नाउ इफ योर वाटर कंटेन्स कैल्शियम और मैग्नीशियम सॉल्ट्स, देन इंस्टेड ऑफ फॉर्मिंग लादर देयर इज अ रिएक्शन गोइंग ऑन इनटू योर वाटर. राइट, वो क्या रिएक्शन है? रिएक्शन ये है, कैल्शियम के सॉल्ट बन जाते हैं बिकॉज Ca2 प्लस होता है, तो two of these soap molecules will join the calcium and this is water insoluble. तो आपको क्या करना पड़ेगा? आपको पहले ये रिएक्शन करना पड़ेगा, सारा का सारा कैल्शियम यूज करना पड़ेगा जितना पानी था, उसके बाद की झाग बननी शुरू होगी. So this is a reaction that happens due to which we call, and this is called scum. This is water insoluble. This is a general equation. ये इक्वेशन को सेम मैंने ये जनरल बना दिया कि भाई कैल्शियम जरूरी नहीं है कैल्शियम हो, इट कैन बी कैल्शियम, मैग्नीशियम, आयरन, एल्यूमिनियम, मैंगनीज और N प्लस, उसके हिसाब से यहाँ पे हमारे पास सॉल्ट बन जाते हैं. नाउ हार्डनेस इज ऑफ टू टाइप्स. कौन कौन सी? एक होती है टेम्पररी हार्डनेस और दूसरी होती है परमानेंट हार्डनेस. व्हाट इज टेम्पररी हार्डनेस? द हार्डनेस ड्यू टू द प्रेजेंस ऑफ बाइकार्बोनेट्स ऑफ कैल्शियम एंड मैग्नीशियम. ऊपर हमने क्या पढ़ा था? दैट कैल्शियम एंड मैग्नीशियम सॉल्ट्स प्रेजेंट हैं, या आयरन के सॉल्ट्स या एल्यूमिनियम के या मैंगनीज के सॉल्ट्स प्रेजेंट हैं, तो हम उसको बोलते हैं हार्ड वाटर. टेम्पररी हार्डनेस में देयर आर बाइकार्बोनेट्स ऑफ कैल्शियम एंड मैग्नीशियम या किसी और चीज के प्रेजेंट हैं, तो हम उसको टेम्पररी बोलते हैं. सर व्हाई डू यू कॉल इट टेम्पररी? वी कॉल इट टेम्पररी बिकॉज इट कैन बी रिमूव्ड. कैसे? टेक वाटर एंड बॉयल इट. आपने उसको बॉयल किया, बॉयल करने से क्या हुआ? जो बाइकार्बोनेट्स हैं they get changed into carbonates or hydroxides, and interestingly calcium carbonate and magnesium hydroxide, they are insoluble in water. Here is an equation. calcium bicarbonate है, you heat it, right? आपने कैल्शियम कार्बोनेट को हीट नहीं कर रहे हो, आप पानी को हीट कर रहे हो जिसमें कैल्शियम बाइकार्बोनेट प्रेजेंट है. तो हुआ क्या? हुआ ये कि कैल्शियम कार्बोनेट जो है प्लस वाटर plus carbon dioxide, which will, you know, when you will heat it, it will fly off. Magnesium bicarbonate hai, if you will heat it, it will become magnesium hydroxide plus CO2, right? Carbon dioxide nikal jayegi, and calcium carbonate is insoluble in water. Similarly, magnesium hydroxide is also insoluble in water. This is called temporary hardness of water. Let us move to next type of hardness, which is permanent hardness. Now, rest of the hardness due to chlorides, sulfates of calcium, magnesium, and other heavy metals is called permanent hardness, and you cannot remove this hardness by boiling of the water. We will continue with this lecture in the next class, but before we move, there are some important questions. Question number 1, sir, आपने बोला कि हार्डनेस कैल्शियम क्लोराइड के कारण भी हो सकती है, हार्डनेस कैल्शियम सल्फेट के कारण भी हो सकती है, हार्डनेस मैग्नीशियम क्लोराइड, मैग्नीशियम सल्फेट, मैग्नीशियम कार्बोनेट, मैग्नीशियम बाइकार्बोनेट, इन सब के कारण हार्डनेस हो सकती है। और सब जब आप एल्कलिनिटी पढ़ा रहे थे तब आपने बोला था कि एल्कलिनिटी कैन बी ड्यू टू बाइकार्बोनेट, कार्बन डाइऑक्साइड, हाइड्रोक्साइड, कार्बोनेट। सर आपने ये एक स्लाइड भी दिखाई थी जिसमें आपने दिखाया था हाइड्रोक्साइड, कार्बोनेट, बाइकार्बोनेट। एंड सर जब आप मेजर करोगे हार्डनेस को या एल्कलिनिटी को, तो सर आप कैसे मेजर करोगे? इफ हार्डनेस एंड एल्कलिनिटी is due to presence of so many species in water, then how do you express it? सर तो आप हर एक के लिए, मतलब सोडियम हाइड्रोक्साइड प्रेजेंट है तो उसके लिए अलग से आप एल्कलिनिटी फाइंड आउट करोगे, सोडियम कार्बोनेट के लिए अलग से टाइट्रेशन करोगे, सोडियम बाइकार्बोनेट के लिए अलग से टाइट्रेशन करोगे। आर यू गोइंग टू डू डिफरेंट? एंड सिमिलरली सर आयरन का सॉल्ट है तो आयरन के लिए अलग से टाइट्रेशन करोगे। सो दीज आर एन इंपॉर्टेंट क्वेश्चन that we need to answer. That sir, so many species are present in water. How do you measure and express? इतनी सारी species को आप individually measure करते हो या इकट्ठा? And sir, units क्या होते हैं? और सर हमने वो experiment किया था क्लास में hardness और alkalinity वाला, जहां पे हमने EDTA यूज किया था। तो सर हम EDTA यूज करके hardness रिमूव कर सकते हैं? I'm sorry, hardness EDTA यूज करके नहीं रिमूव कर सकते हो, सिर्फ पता लगा सकते हो। सोचो कितना EDTA यूज होगा अगर आपने एक बॉयलर में पानी गर्म करना है जिसमें कंटिन्यूअस सप्लाई रहती है 1000 लीटर, मतलब आ रहा है, स्टीम बन रही है, जा रहा है, तो कितना EDTA यूज करोगे? इट्स नॉट दैट इजी, राइट? तो सर फिर कैसे करेंगे? तो सर EDTA यूज किस लिए होता है? EDTA सिर्फ एनालिसिस के लिए यूज होता है, ये पता लगाने के लिए कि कितनी हार्डनेस है। एसिड किस लिए यूज होता है? एसिड सिर्फ टाइट्रेशन करके हम पता लगाते हैं कि कितनी एल्कलिनिटी है। जैसे आपने यहां पे लैब में एक्सपेरिमेंट किया था, वैसे जहां पे बॉयलर होता है वहां पे एक छोटी सी लैब होती है, वहां पे बिल्कुल प्रिसाइसली सेम एक्सपेरिमेंट किया जाता है। मे बी सम इंस्ट्रूमेंट्स में बी देयर, बट बेसिक प्रिंसिपल ये रहता है। तो सर फिर रिमूव कैसे करेंगे? सर 1000 लीटर में से, पानी में से हार्डनेस रिमूव करेंगे कैसे? दिस इज the topic of our next lecture. Thank you for